Hello and welcome to Azure Data Estate Modernization webinar hosted by the Henson Group. And today we will be doing this Azure Data Estate Modernization webinar to understand that how the Azure platform, the Azure public cloud can help us do the modernization for all sorts of data types, maybe hybrid or it may be for our cloud scenarios and also for the IoT scenarios that we have. Feel free to unmute yourself and ask questions whenever you have any doubt. And let's get started. To understand the current context of what basically the industry puts forward to us is that we have all sorts of data that we require to ingest into our data storage, data processing, analytical systems, and not only store it but also reason over all of our data analytics, business intelligence, and artificial intelligence, the machine learning workloads, and the data science. So the data is coming in all forms and shapes and sizes, from the applications like video streaming applications, from our RESTful endpoints, the application APIs, from real time data coming out of the e commerce applications, the publish subscribe chat based messaging systems that we have for our Facebook and all of the different kind of messaging social platforms, also interactive devices which are streaming the data in real time like the CCTV cameras and IoT devices, and also the Kafka devices or the real time cluster based devices which are giving us a lot of IoT data. All of this data is in very large size, which means the volume is pretty much high. The variety in the data is pretty high because all sorts of data may be structured, semi structured, and unstructured data is coming in. And not only that, we have a lot of value in this data. We not only just want to store it, but want to make and gather wisdom and knowledge out of this data. So the typical use case scenarios that we see in the industry revolve around the hybrid data footprint, where the companies keep certain data that they have for security reasons, compliance reasons, or certain other custom solutions on their on premises, and they have failover approaches or rapid burst approaches to the cloud. So they may have a hybrid data environment where they may be keeping some critical data on prem, and for storing the data on the cloud they may have a cloud vendor, a cloud service provider. Not only that, the companies are looking for true elastic scale compute for heavy lifting on their data, which means for analytics and for AI, machine learning, which are iterative processes. Companies are looking for the cloud because the cloud gives them operational expenditure model, and not only that, it gives them a lot of elastic compute which is required to have these processes running in the company. So the cloud going to provide us the operational databases, customer databases, multi-tenant databases, hyperscale databases. Similarly, the cloud will provide us the data warehouses where we can have historical reporting and the summary and the aggregations on the data, analytics, decision making systems on top of our historical data. Not only that, we can make centralized data lakes for data integration in the cloud. So the the cloud gives us rather the entire gamut of the data storage services, data lake services for centralized storage of raw data, then OLTP systems where we can have operational databases, and also the OLAP systems, online analytical processing systems using data warehouses. And not only that, on Azure, we can also do the artificial intelligence. We can use the Azure intelligent devices or Azure intelligent cloud with its all cognitive services to reason the data out of these stores. Going forward, we have to also understand what are the different triggers that pave the way for the modernization. Why do the decision makers in the company, all the executives, will look at cloud? What is there in cloud that drives these decisions for the data estate creation? So, if we look at the reasons, the primary reasons are data center contracts expiration. So, if you are having a data center lease and that data center lease is expiring, then rather than your chief finance officer saying you that let us invest more to have a lease, rather than doing that, you could basically get it from the cloud services provider. Similarly, when multiple acquisitions are made for the data, then you could have them going into the cloud, which means you could rapidly get that compute capacity and storage capacity from the cloud rather than provisioning it on prem on your own land, right? On premises a data estate, which is not that very easy because the timelines of setting up an on premises data center are measured in months or quarters rather than in days or hours as it is on our cloud. Similarly, the capacity needs of the companies are pretty much evolving, right? So the developers are growing more and more demanding from the operational teams that we want databases and data storage layers which do not suffer from any kind of a downtime, which very rapidly scale in, scale out as the need arises, and the high availability in our backend should be very, very high. As a result of which, the capacity needs for scaling the data store is also measured in hours, not in hours, rather in minutes, right? In seconds. You can scale on cloud, scale up and scale down on the cloud. Similarly, the pace at which the cloud data centers, which means the cloud service provider data centers, are updated with modern hardware and latest and greatest software updates, that for us to do we require skilled labor workforce on the DevOps side who can look after all of these kinds of issues, where we could purchase more and more newer hardware and update our softwares, which will be a very, very capital expenditure oriented work, right? So it will give us a lot of upfront investment which the startups and the digitally modernizing companies will try to avoid. Similarly, we will have security threats. The public cloud platform learns from lot of security threats that are already being attempted on the data storage kept in cloud, as a result of which the cloud service providers have a better threat management and better security against all of these modern threats which a private data center or an on-premises data center may not have. Similarly, they also use the machine learning to identify the patterns of access onto your data, that whether this is some kind of a security threat, that is the vulnerability assessment of the data stores are conducted by the cloud services provider. Similarly, the cloud gives us a lot of compliance across the law of the land and also the industry compliance levels. Maybe if you have PCI DSS compliance, if you are HIPAA compliant, or whatever compliance that you are obeying for your projects, the data stores that are on cloud are certified, which means the Azure data stores are certified for all different kinds of the compliance levels. The developers, on the other hand, are growing more and more demanding, and they desire application innovation where their focus should be on getting more and more features built into the platform rather than thinking about the operational aspects of the data stores. So, how to create a globally distributed databases, how to create data pipelines, how to create a database which is automatically highly available, highly availability should be industry grade. All of these things which are the operational issues regarding the data stores, the developers don't want it, as a result of which modern cloud applications want backends which are innovative, and they are not at all, uh, which means of the olden days. Also, you may be suffering from end of support on your data services like your SQL Server 2008 release 2, right? But if you migrate to cloud, then they will give you the free support for that. So these are few reasons that we must remember when we think about a modernization trigger. So what is happening in our current environment, and why should we look up at the cloud? Because cloud gonna give us a lot of advantages when we create the data estate on the cloud. The startups which do not have deep pockets to do any sort of capital expenditure and upfront investment, and similarly the companies which are digitally modernizing, they also need to look up at cloud because they only want the operational expenditure rather than upfront investments. Rapid scaling through elastic scaling, usage of leveraging the latest and the greatest hardware generations on the cloud, better security management on the cloud, compliance levels is what we want for whenever we are building an enterprise grade data storage solution. This webinar focuses on that how can we build a hybrid data estate and modernize our data estate for all sorts of data, right? Big data. So we are talking about all variety of data, high velocity, high volume, high variety, veracity, which is data quality issues, that whether the data is reliable enough to take decisions upon, and also the value. So we will think of our data as a very big data, and we will try to make a hybrid data estate using data modernization to Azure. And we will also learn that how Azure will give us cloud scale analytics, rapid scale, and rapid um, pipelines, and all of these different things which you require for your data integration tasks. Looking at this slide highlights that what are the different services that are available on the Microsoft Azure platform. So if you see over here on the on premises or the hosted environments, if you have a big data application which you want to develop, which means you want to crunch a lot of data, which is big data, and for that, for relational OLTP system as well as for OLAP, we can use SQL Server 2019, and the SQL Server 2019 modernize applications across cloud and edge both. The benefits of SQL Server are we can have any choice of operating system because SQL Server supports both the Windows and the Linux environments from 2017 onwards, because Microsoft got the Linux support in SQL Server on 2017. The development environment is available when you create the developer edition. Choice of deployment is there, whether you want to deploy it on your own hardware box, whether you want to deploy it on Kubernetes clusters, or do you want to deploy it on cloud. That is all up to you. The lowest total cost of ownerships are observed in the industry when we talk about the on-premises hosted environments of SQL Server. It gives us the strongest security and the best performance. If you think about lift and shift and software as a services, we have for relational, we have Azure SQL Database, which is a singleton standalone dedicated database with its own compute, data, and memory resources. So it is for the greenfield projects, which is the projects which are starting new. Microsoft recommends that the designers, solution architects, must use SQL database because it's a single database. So for scenarios like database per customer, multi-tenant databases, and a single dedicated database without any headache of the SQL Server specific requirements, we can have Azure SQL database. Similarly, other open source technologies which are Azure MySQL, Azure PostgreSQL, Azure MariaDB, these are also offered as fully managed database services. They are intelligence, they gather a lot of performance metrics and performance insights from your workloads. Automatic true auto scale is there in these services, and high availability is built in using cluster based technologies. Earlier we used to put in a lot of effort for the always on availability groups and all of these different things, that like the active log shipping, the availability groups, distributed availability groups, right, failover cluster instances. All of that is taken care by the cloud service provider, which is Azure, in our case Microsoft Azure. It gives us advanced security. So, security like vulnerability assessment, threat protection across threats like your SQL injection and the SQL injection vulnerability, anomalous logins, and cross site request forgery. All of these different kind of advanced threats need to be identified using advanced data security, dynamic data discovery, dynamic data masking, data discovery and classification. All of these are different security levels that are required within the company for the data. It is most compliant with all of the law of the land and the industry standards like HIPAA, PCI DSS, ISO, all of these things. And we get choice of RDBMS flavors on the Azure platform. So you can go with Azure SQL database, which is a flavor of SQL Server database engine. You can have other open source technologies, MySQL, PostgreSQL, and MariaDB. These are relational systems. On the other hand, if you want a document database or a key value store or a white column family or a graph database, these not only structured databases, not only SQL databases, no SQL databases are offered on the Azure platform using Azure Cosmos DB. Azure Cosmos DB is Microsoft's evolution of the document DB, and here it is a globally distributed database for cloud native applications. It has a feature called as turnkey global replication, where you can create a full master copy, read write copy, that is to say, of your database nearest to your customers, wherever your customer base is. It allows you to have true elastic scalability of both the storage and the throughput. It gives us single digit latency guarantees in the order of 10 to 15 milliseconds across the world. That is unparalleled, right? And it has leading SLAs up to 5 nines of high availability in the multi-master replication model or geo-redundancy model. Most of the NoSQL databases support only two consistency models, that is strong and eventual, whereas the Azure Cosmos DB is the only database currently in the industry which supports five well-defined consistency models, namely strong, bounded stillness, session, consistent prefix, and the eventual. It has support for most of the popular APIs that we see in the industry, like the MongoDB API, the SQL API, similarly, the Gremlin API for graph databases, MongoDB API, Table API for key value stores, and the Cassandra API for the white column family. For analytics on the Azure platform, we have the Azure Synapse Analytics, modern data warehouse leveraging the open source softwares and the governance model, Azure SQL Data Warehouse, Azure HD Insight, Azure Data Lake Service, Azure Databricks, which is the in-memory cloud computing framework for our big data, which is based on the Spark, Apache Spark project, Azure Data Factory for data integration requirements, Azure Data Catalog for documentation of our data sources, Azure Stream Analytics for processing the incoming streaming data, and Power BI for our visualization, reporting, and dashboarding. So it gives us global scale for our analytical projects. Security and privacy is top notch, and it gives us best of the open source and Microsoft AI innovation. Namely, the Databricks is an open source software HD Insight, which is based upon the Hadoop clusters and all of these different Spark clusters. These things are also based upon the Apache Hadoop open source project. So we get the best of the open source and Microsoft AI innovation. We can also deploy ML models on premises, in the cloud, or on the edge. Right? Any question till this point? Otherwise, we're going to be proceeding with the rest of the discussion. Okay, so let us proceed and let us go ahead. So let me go again and say full screen mode. Let me quickly check. Any question? No. Okay, fine. So let me go again and do this. So full screen mode. So in this slide, we have seen that how the different services are on our Azure platform, which is going to give us a lot of different things. Now let us start discussing about the SQL Server. So Microsoft created the SQL Server 2019. For 25 years, Microsoft SQL Server has been powering data-driven organizations. We all know that as a variety of types of data and the volume of the data has risen, the number of types of databases has risen dramatically. Over the years, SQL Server has kept pace by adding support for XML, JSON, in-memory, and graph data in the database. It has become a flexible database engine that enterprises can count on for industry leading performance, high availability, and security. However, we must understand that a single instance of SQL Server was never designed or built to be a database engine for analytics on the scale of petabytes or exabytes. It was also not designed for scale out compute, for data processing or machine learning, nor for storing and analyzing data in unstructured formats such as media files. SQL Server 2019 extends its unified data platform to embrace big and unstructured data by deploying multiple instances of SQL Server together with Spark and HDFS Hadoop distributed file system as a big data cluster. So we are not only talking about SQL Server 2019 over here in terms of its OLTP, online transactional processing capabilities. We are also discussing the SQL Server 2019 from analytical perspective, which is the OLAP. It is industry leading performance and security with intelligence over all of our data. It gives intelligence over any data, SQL, pools, and the Spark engine is natively embedded into the SQL Server 2019, which allows us to analyze over structured and unstructured data with the power of SQL and Apache Spark. Because Spark is embedded within the SQL Server 2019, we have all the choices of platform and language natively, namely the Linux, Windows, Kubernetes. So the when Microsoft added support for Linux in SQL Server 2017, it opened the possibility of deeply integrating SQL Server with Spark, the HDFS, and other big data components that are primarily Linux based. SQL Server 2019 big data clusters take that to the next step by fully embracing the modern architecture of deploying applications as containers on Kubernetes. So you see on the icon, you see on the slide the icon of Kubernetes, and deploying SQL Server 2019 big data clusters on Kubernetes ensures a predictable, fast, and elastically scalable deployment regardless of where it is deployed. Big data clusters can be deployed in any cloud where there is a managed Kubernetes service, such as Azure Kubernetes Service, or in on premises Kubernetes clusters, such as AKS on Azure Stack. T-SQL, Transact SQL, Scala, Python, Java, Node.js, Ruby, C, C++, C Sharp, VB.NET, .NET Core, all of these languages are natively supported within SQL Server for your analytical requirements. It gives us the industry leading performance, right? It is being marked as number one on the OLTP performance in the TPC benchmark, transactional processing performance benchmarks council, TPC benchmarks, and it is also number one on the data warehouse performance on 1 terabyte, 10 terabyte, and 30 terabyte concurrent queries. It is the most secure over the last 8 years, and insights in minutes and rich reporting can be done using Power BI and SSRS engine. And all of it comes at one tenth of the cost of Oracle in light of a friendly comparison. So it only is one tenth the cost of Oracle. So if you are targeting a modernization of your on premises data state, where you may have some sort of a relational database engine sitting over there, and your data volume, your data size, your data velocity, your data types, your data variety is rapidly changing and evolving, then you can look at your SQL Server 2019 because it supports all sorts of big data analytical processing and machine learning and intelligent services on the Azure platform. So it has in-DB advanced analytics through Power BI and the Power BI reporting server. We have mobile business intelligence through Power BI mobile, and self-service BI we can always do using Power BI desktop and the Power BI service. It has been marked number one in the Transactional Processing Performance Council TPC benchmarks for data warehousing. It has built-in ETL using SSIS SQL Server Integration Services, and it is an industry leader already in the OLTP space. So if you look at the difference in what is the difference in the cost, it is 11 times cheaper than the Oracle, which is the primary competitor of SQL Server, in light of friendly comparison. Oracle requires separate support costs and penalizes customers for reducing the usage, which is not there in the SQL Server. SQL Server 2019 enables intelligence all over your data, and this has to be pretty much understood that if you have any kind of a requirement of ML or data science on top of data kept in the SQL Server, then you can do so. SQL Server 2019 big data clusters make it easier for big data sets to be joined to the dimensional data typically stored in the enterprise relational database, enabling people and apps that use SQL Server to query big data more easily. The value of big data greatly increases when it is not just in the hands of the data scientists and the big data engineers, but is also included in the reports, dashboards, and applications. So, using SQL Server, we can integrate all our data, unified access to all data with unparalleled performance using the Polybase feature and the SSIS feature of the SQL Server. We can manage all the data easily and securely because it is a cluster based approach for data storage rather than a single instance. And it gives AI all over our data, AI over all of our data. And we will like to elaborate on this because AI is very, very important. SQL Server 2019 big data clusters provide a complete AI platform. Data can be easily ingested via Spark streaming or traditional SQL inserts and stored in the HDFS, relational tables, graph, or JSON/XML. Data can be prepared by using either Spark jobs or Transact SQL queries and fed into machine learning model training routines in either Spark or the SQL Server master instance using a variety of programming languages, as we have already seen on the previous slide, including Java, Python, R, and Scala. The resulting models can then be operationalized in batch scoring jobs in Spark. In Transact SQL, stored procedures for real time scoring or encapsulated in REST API containers hosted in the big data clusters. So it gives us simplified management and analysis through a unified deployment, governance, and tooling. This is the same slide which I have elaborated right now to you, that we have data virtualization. Data virtualization is a different approach than ETL processes that we perform on our data, extract, transform, load processes that we perform on our data. So while extract, transform, and load has its own use cases, an alternative to ETL is data virtualization, and which integrates data from disparate sources, locations, and formats without replicating or moving the data to create a single virtual data layer. Data virtualization enables unified data services to support multiple applications and users. The virtual data layer, sometimes referred to as a data hub, allows users to query data from many data sources, right? The SQL Server 2019 Big Data Clusters, with enhancements to Polybase, the Polybase technology that we have, acts as a data hub to integrate structured and unstructured data through what's referred to as SQL Server external tables. And then it can be put on the compute pools and data pools for storage and analysis. We all understand that SQL Server and Spark are deployed together with HDFS to create a shared data lake. So we can manage all type of data rather than only relational data OLTP system. We can manage all types of data. So it helps us create a managed data lake with SQL Server and Spark. And there is an admin portal also in the SQL Server which helps us do the log analytics, monitoring, backup, and high availability through an administrator portal, ensuring a consistent management experience wherever a big data cluster is deployed. So the scalable shared storage for our SQL Server 2019 is HDFS, Hadoop Distributed File System, and SQL Server Relational Engine and the Spark engine both are natively deployed as container on the Kubernetes environment for our modern data needs. And we have already discussed that it provides us a complete AI layer as well, intelligent machine learning layer on top of our data, not only relational and OLAP, but also the modern AI workloads, which are quite iterative in nature and require a lot of compute power, right? So to just repeat, I would like to just again highlight that how important this thing, which is the AI, is. So data scientists can choose either to use SQL Server machine learning services in the master instance to run R, Python, or Java model, or they can use Spark and Spark MLlib. In either case, the full library of open source machine learning libraries such as TensorFlow or Caffe can be used to train the models. Okay. SQL Server is the hub for integrating data. So if you have data integration needs, multiple departments within your organization are recording the data in different data stores. And for centralized reporting, centralized analysis, and different kind of requirements, you can integrate it using the Polybase technology, right? So ODBC, Open Database Connectivity, IBM DB2, Excel, SAP HANA, Not only SQL structures, not NoSQL databases like Azure Cosmos DB, MongoDB, relational databases like your SQL Server, SQL Database, SQL Data Warehouse, Teradata, Oracle, and big data Cloudera distribution of your Hadoop and the Hortonworks distribution of Hadoop. Here, from all of these data sources, you can bring in the data into your SQL Server 2019 in using a technology which is called as Polybase. This is little bit of the big data cluster layout. We are not concerned with the architecture, but we have to understand that we are doing here the deployment in a containerized environment for rapid scaling, because the containerized environment gives us a very rapid scale. So you see Kubernetes nodes which are giving us the persistent storage, and then on the Kubernetes nodes we have the Kubernetes pods, which are nothing but our HDFS data node on top of the same node or the same pod we are running the Spark engine and the SQL Server engine. And then there are compute pools also, SQL compute nodes, which are going to process this data. For storage pool is for our semi-structured unstructured data needs, and the data pool is for our relational data needs. And we can develop the architecture for our modern data needs, big data needs on top of this rapidly scaling containerized environment. This was all about the data modernization on premises, that if you have a SQL server running on prem, you want to remain on prem, but you would like to modernize your SQL server, then SQL Server 2019 gives us the wings to modernize the data platform. Now we talk about data modernization to Azure, that how you can modernize your data on the Azure platform. So let's go ahead. So Azure Data Platform gives us intelligent performance metrics. So Azure SQL Database Intelligent Insights. Similarly, for all the other offerings also, there is Intelligent Insights. For MySQL we have, for PostgreSQL we have. And it gives us the highest top-notch security. You may have heard of private links and private endpoints, which are only available on the Azure platform. The VNet isolation for the compute layer is also available on the Azure platform. Apart from that, Azure Defender for SQL, which was earlier referred to as the Advanced Data Security, which is a premium paid offering of the data storage services, which gives us the security technologies like data discovery and classification for compliance needs, auditing, automatic threat detection, vulnerability assessment, all of these different things, always encrypted. These things can be taken through the security. Hyperscale is also available on the Azure data platform. And hyperscale means that the databases which need to grow beyond 4 terabyte limit. So the Azure SQL database has a limit of 4 terabytes. You cannot grow your database more than 4 terabytes. Similarly, for Azure SQL managed instance, you cannot grow your database beyond 8 terabytes in the general purpose service tier. So if you have a database which you want to grow beyond 4 or 8 terabyte, you have to look at hyperscale database, amazing offering. We will talk about this also within a short while. So we have the Azure SQL Database, Azure SQL Data Warehouse, which is now referred to as Azure Synapse Analytics, SQL Pools, Azure Database for PostgreSQL, Azure Database for MySQL, and Azure Database for MariaDB. Intelligent advisors, tuning and monitoring is supported, flexible independent scaling of compute, and storage can be done. And there is a lot of resource governance that is available on the data platform. High availability and disaster recovery is natively built using the Azure application. The geo replication gives us the high availability and DR setup both, where we can create four readable copies of our database in the same or the different region. For example, if you create a SQL server or Azure SQL database, let us say in Eastern United States, and if you configure active geo replication for that database hosted in Eastern United States, you can configure up to four replicas of that database in the same region for high availability or in different region for disaster recovery. Similarly, for disaster recovery, you also have auto failover groups where the group of databases can fail over to a secondary region. The backup and restore methodology is available as usual. The Azure SQL database takes the full backup of your database every week, and a differential backup is taken every 12 to 24 hours, and a transaction log backup is also taken every 5 to 10 minutes. And we can do a restore using these backups from these restore points. Security audit and VNet isolation and private link is also supported, which we will talk about. Globally available in 54 regions. If you add all the Azure government regions, the tally goes up to 60 plus regions. And all the advanced services like Power BI, Azure App Services, Azure Data Factory, Azure Analysis Services, Azure Machine Learning, Azure Cognitive Services, Azure Bot Service, they natively integrate with the data platform. There is no need for you to worry about how to integrate them with my data services. They natively integrate with all the data services. Anyone who thinks about cloud to store the data, to process the data, also has on the mind security. Without proper security, nobody wishes to come on cloud. That is the reality. So Microsoft is the leader in security of the Azure cloud platform, and $1 billion is invested, dollars are invested per year just for the security posture of the Azure public cloud. You can protect the data using the Azure threat protection against the threats like cross origin request services, cross site request forgery, cross site scripting, SQL injections, dynamic SQL vulnerabilities, anomalous logins. And you can also get an assessment, vulnerability assessment report of your security posture. And this can be mailed to the administrators, whomsoever you want that reports to go to, so that they can look at those reports and take further security hygiene requirements. You can preserve the confidentiality of your data with features like dynamic data masking, data discovery and classification, and also the always encrypted, which is nothing but your column based encryption. So that will even encrypt the data from the administrators, the elevated accounts that you have in your database. So any elevated account that you have in your database, that can also be data can also be preserved, the confidentiality from them, if you have always encrypted with data classification. You can manage the security using the security policies centrally using the Azure Security Center. So the vision of the Azure platform is to centrally manage and drive the security through policies, policy driven security for both your on premises and cloud assets. This is a very important slide, and this slide highlights that there are two kind of customers that are looking for data modernization requirements. One are the people who want to preserve the operating system support and also the SQL server specific features like database mailing functionality, common language runtime, and SQL server broker, database distributed transaction coordinator. All of these different server specific features, if they want to preserve it, they want to preserve operating system support also. They want to utilize the full value of their license by natively running other engines of the SQL server, like the analysis engine, reporting engine, integration engine, on the same machine where the database engine is running. Then they can come on the Azure SQL VMs. Also, if they are having any kind of a support requirement from their vendor for OS level access. So managing VMs for OS layer, including provisioning, scaling, patching, HADR, backup, and upgrading. It is backward compatible with all of the previous offerings through what's called as a compatibility level setting, which is a database level setting, which we can very easily set using the alter database set compatibility level equals to whatever the compatibility level we want. It has a full surface area of SQL Server because it's a SQL Server running on an Azure VM, right? You are creating an Azure VM and you are deploying SQL Server on that, or either you go to the marketplace image and pick an image from there, Azure SQL VM image. Instance will face end of support, obviously, and currently Microsoft is giving extended security updates for free for SQL Server 2008 release 2. We all know that a SQL Server release remains for 5 years in primary support, then next 5 years in extended support, and then it has end of support. So SQL Server 2008 release 2 is already out of support. End of support has been reached, but they are giving us an incentive whereby if you bring your SQL Server 2008 which you are running due to some reason on prem on the cloud, they're gonna give you the free extended security updates on the SQL Server 2008 release 2. So Azure SQL VMs are best for your rehost, which is lift and shift kind of requirements. Similarly, you also have Azure SQL Database, which comes into three flavors: SQL managed instances, a singleton dedicated database, or elastic pool of databases where we can purchase the capacity for a group of databases rather than single databases. So highest version with latest features, the end of support. There is no end of support for your this thing, Azure SQL database. Azure SQL database is a versionless database, and basically it is always compliant, it is always up to date with the latest SQL Server Enterprise Edition database engine available in the market. Intelligent performance and security, improving productivity, built in high availability on a single node. So we don't have to configure any always on availability group or a failover cluster mechanism or anything for that sorts. It has built in high availability for 4 nines. Independent scaling of compute and storage through the vCore based purchase model can be done for the Azure SQL database. Azure SQL database is good for rehost, lift and shift, as well as for re-architect cloud apps. So if you are re-architecting cloud apps, Azure SQL database is good. Singleton database or elastic pool. For rehost, lift and shift, the managed instance is very good. Managed instance gives us SQL Server specific features without the operating system access. This was a study conducted by the Forrester Consulting for Microsoft. Microsoft commissioned Forrester Consulting to conduct a total economic impact study to examine potential cost savings. And these are some numbers which highlight the effectiveness and the efficiency of the managed instance. So if you look at key report benefits and findings, we can clearly see 212% total return on investment was get they got that kind of a ROI 3 years after initial investment and migration to the Azure SQL database. managed instances, and the payback post migration was hit 6 months. So the cash inflows minus the initial investment was realized within 6 months. Similarly, dollar 1.8 million was saved from hardware, network storage, ongoing maintenance cost, and the effort and the productivity of the database administrators were also improved 40%, and 20% increase in productivity for IT teams was also realized. Similarly, if we talk about our requirements, the current limit of the database size that we have on Azure SQL database and the Azure SQL managed instance is namely 4 terabyte and 8 terabyte. So Azure SQL database will not allow you to grow beyond 4 terabyte. Similarly, the Azure SQL managed instance will not allow you to grow beyond 8 terabytes in the general purpose service tier. But imagine a world where you have a limitless database. There is no limit on the size of the data that you want to keep. Backup is natively taken for you, zero performance impact of backup. Backup is a very, very resource intensive task, and all the database administrators will bring the database offline before doing it. So, backups have zero performance impact. Cloud database which supports up to 100 terabyte and more, limitless database size. There are no data size operations which it cannot do. Accelerated database recoveries are provided for restores, and the compute is also given, which is scale up and down happens in minutes, not for hours, for both storage and compute. Very, very rapid scaling. Is it possible for such a kind of a database to be realized on the Azure platform? Yes, we have an offering which is the Azure SQL Database Hyperscale offering. This Azure SQL Database offering has a scale out architecture both for the query engine, the relational engine, as well as for the storage engine. So it has a scalable new storage architecture. It is cloud native for architecting for cloud. It allows us to grow our database size to 100 terabyte. The currently documented maximum size for data is 100 terabyte, and the transaction log is currently documented to be limitless. There is no limit for transaction log. Seamless compatibility, fully compatible with the Azure SQL database. Performance, very large database operations without the very large database headaches. So there is nothing that you have to do regarding backup and restore, database consistency checkups, any sorts of operations along the VLDB lines you don't have to do. And there is no limit scale and compute. Currently there is no limit, and large database 100 terabyte plus size is what Microsoft is trying to give you, and this is super modern, right? It is for big data scenarios where the companies will have a single database storing all of their hyperscale data. Similarly, if we put a little bit of attention towards the open source database products on the Azure platform, you can see MySQL, PostgreSQL, and MariaDB. It gives us more choices and full integration into Azure's ecosystems and services. They are built on the community image of the MySQL, PostgreSQL, and the MariaDB. We can perform easy lift and shift using these community based MySQL, PostgreSQL, and MariaDB. We have different languages and frameworks of our choice. The flavors of the SQL that is available on top of these community softwares. Scale in seconds with built-in high availability. All of them utilize the Azure storage for high availability, and the scaling is very, very rapid. We don't have to take a lot of headache in scaling them up. Timelines of scaling are measured in seconds and minutes rather than in hours. They are secure and compliant with the all Azure Service Fabric security. Industry leading global reach is also there. So if you look at one click integration without need to provision, you don't have to provision any Citus architecture or anything. The intelligent database insights are given to you by looking at your workloads. So the database IO and data IO and the CPU compute queries are identified, resource intensive queries are identified, the longest running queries are identified. All of these things are identified for you so that you can get a head start into performance tuning aspects of your database. Built-in ATP is there, as I've already told you. Threats against SQL Server injections, dynamic SQL, cross-origin request services, XSRF, the cross-site request forgery, and all of these advanced threats can be mitigated using the ATP offering. It has a global reach two times as per the data center versus the AWS RDS for open source systems, because it is available across all the different regions. If you look at the pathway to modernization databases to the cloud, we have to understand that the database migration service is very, very important for migrating our databases to Azure. So we have to see the three different kind of environments. One is Azure SQL database, SQL Server on an Azure VM, and Azure database for MySQL, PostgreSQL, and MariaDB if open source is your choice. All of them give us 50 to 80 to 90% of cost reduction as compared to AWS. Obviously, this is with Azure hybrid benefit, which means you are utilizing the hybrid license, which means you are utilizing the license mobility program of Azure, and you are using the license mobility program for your uh, cost reduction, and you are also using the Windows license also, which is a hybrid license, right? Reservations can also be done to reduce the cost. SQL Server on an Azure VM is running. Auto patching and auto backup is possible using SQL Server VM resource provider, and managed services using language and framework of your choice can also be done in the MySQL, PostgreSQL, and MariaDB. And all of them scale dynamically. We don't have to think about any of the sorts. So for our data migrations, if we have taken a decision that we will be doing a migration to the Azure, then from our data sources like SQL Server 2005 or onwards, 2017, Oracle, MySQL, PostgreSQL, MariaDB, Sybase, we can assess these environments using what is called as a DMA, data migration assistant, and we can migrate it using the SSMA, which is SQL Server Migration Assistant. For our structured data sources like the SQL Server and Oracle, we can use Azure Data Migration Service, Database Migration Service, which can help us do cloud migration at near zero downtime. Near zero downtime. So the database migration service gives us an online mode of migration where the downtime is only limited to the cutover performed at the end of the migration process. It gives us free DMS for offline migration and free online migration up to 6 months with 4-week course. Premium data migration service for our data migration requirements. Microsoft has a comprehensive customer support program for customer modernization to Azure. Pre-sale activities are performed, which identify workloads, scope the POCs, and conduct the workshops with the client. Ability to support overall IT priorities Broader and deeper on-site account coverage is also performed. POC and trials are also done. You can have a 30-day free trial for all Azure data services free of cost. Extend the trials and additional Azure compute available for qualified customer scenarios. And investment for customers to try before they buy. Risk free billing meters turned off. Migration tools, as we have already talked about, are offline and online, and online and offline both are free. Online is only free for the first 6 months with 4-week course. No such kind of free online migration is supported on the AWS. So broader set of migration programs support both like to like and heterogeneous migrations, direct engineering support, target architecture, POC execution, migration project quality control, funding on POC, extended free trial and Azure credits for any deal size with justified ROI or impact. Azure SQL Database is a dedicated database for modern cloud applications. Unparalleled security with the Azure Defender for SQL is provided, and the performance of SQL in a fully managed environment is realized. It has built in intelligence, machine learning based performance, and security is provided. Trust and privacy is there. The by default SLA is 99.9949 of SLA is there on the SQL product, and the industry leading security and privacy capabilities are present in the Azure SQL database. Seamless compatibility is also there. It is compatible with all the previous versions of the SQL Server database engine, and it also has competitive total cost of ownership along the friendly comparison with AWS, but with Azure hybrid benefit, that is, you are utilizing license mobility program. Another offering that you should be keeping in your mind is the Azure SQL Database Managed Instance. And the Azure SQL Database Managed Instance is for lift and shift kind of scenarios, migration scenarios, lift and shift migrations. Azure SQL Database does not have any server specific feature, it is only a database. So if you require service specific features but without any headache of doing infrastructure as a service like SQL Server running on a VM, you can do SQL Server, you can do Azure SQL Database Managed Instance, which will give you near 100% compatibility with the SQL Server Enterprise Edition database engine and all the SQL Server specific features because it's an instance. So you can assess your environment through the data migration assistant tool. So you can use the data migration assistant tool to check the feature parity and the confirm the compatibility levels. Create a managed instance. The managed instance deployment is similar to how you deploy it on-prem, your SQL Server, which means network environment, and then create the managed instance. And then migrate using the Azure Database Migration Service with a premium offering. They're going to give you online migration support, which will give us near zero downtime because the downtime will only be limited towards the end of the migration where we shall perform the cutover. It comes into three service offerings, service tiers. We call them service tiers. The service tiers are the general purpose service tier, the hyperscale service tier, and the business critical service tier. If you look at the general purpose service tier, it's most budget oriented. The compute tier will be in the 8, 16, 24, 32, 40, 64, 80 V cores. So up to 80 virtual cores you can have for your query processing engine. And independently, you can configure the storage also from 32 gigs to 8 terabyte per instance. And a single instance can have up to 100 databases. The hyperscale is going to be rolled out pretty soon on the SQL Database Managed Instance, which will give us data size up to 100 terabyte. And then you also have the business critical offering, where you can have 8, 16, 24, 32, 40, 64, 80 v cores, and again 32 GB to 4 terabyte per instance, right? So you can see in the general purpose the maximum size of your instance can be 8 terabyte, and in the business critical it is 4 terabyte. As we have already talked about, that you may have a requirement for coming to Azure virtual machine, which means SQL server running on an Azure virtual machine. So if you want full operating system control on your machine where SQL server is running, you want to maximize the value of your SQL server license because you want to natively run other engines along with the database engine, and you require all server specific features, then you have to come to SQL server on an Azure virtual machine. Secure and compliant, seamless cloud migrations are supported. Flexibility and control with automation is there. Automatic security patches and automatic backups are taken using the Azure SQL VM resource provider, which is not available on the EC2. And it also has leading total cost of ownership, which means you can save up to 43% versus the EC2 with the Azure hybrid benefit. This company, this case study is very, very interesting. Intershop, which is one of the communications company, has given this review that customers are applauding us now that we offer our commerce shop 7.10 based on the Microsoft SQL Server and the Azure SQL database. They simply choose either to deploy on premises and or in Azure, and off they go. Everything is built in and the cloud service is fully managed. The significant performance gain compared to another database offering clearly exceeded our expectations. We have thus achieved a much improved market access with our solutions. So you can see that how the Azure SQL database and the SQL Server running on a VM is helping people achieve better efficiencies, better effectiveness, and better return on investments on their data estate, right? So this finishes our second agenda where we discussed about how to modernize our data estate for relational data on the Azure platform. I will check for questions at this point, and if we have no question, then we will proceed. Okay, no questions. Fine. So let us proceed. So as you can already see that we can utilize the Azure platform for relational database offerings, and not only relational data offerings, the applications that the developers are developing. One of the application, maybe your application today works for single pin code, but the company expands and becomes a global leader, and the application that the developers are writing is for the entire globe, right? Think of, let us say, e-commerce application like Amazon. First it is in some geographical locations, then it is planned to scale within 10 years. So we require a database that grows along with the business, right? And we don't want to do any kind of movements and all of these things. For that, how to build globally distributed databases, which means to bring the data closest to the end users for both read and write, so that their performance, so that their experience on the front end layer of our applications are streamlined and highly responsive. So globally distributed data is also very, very important. So this tells us that if we are developing modern cloud native applications and multi-model apps with Azure Cosmos DB, it has global distribution. It is the first and the only database in the industry which has turnkey global distribution capability, which means you go to the Azure portal, you create your Cosmos DB in a primary region, let's say Eastern United States. They're going to create a read and a write copy for you in the Eastern United States. And then there will be a page called as Geo Application on the Azure portal, you can go over there, and from all the regions of the world, you can configure where you want a full readable and a writable copy of your database to sit. So wherever your customer base is growing, you can just click a single click and tell them that, hey, please create a full readable and a writable copy of my database nearest to these customer base. It has multi-model, multi-API. The Azure Cosmos DB stores the data using what's called as atom record sequences, but it has different APIs, namely your SQL API, which gives developers the familiar transact SQL statements to query the data. It's a document database model. Then you have MongoDB API. If your developers are targeting a MongoDB backend for a planet scale database because they are doing a mean and a mon application, that you can do so using the MongoDB API, which is again a document database, document model. Similarly, you have the Graph API, Graph Model, Gremlin API, which we have, the Cassandra API, which is for wide column family, and then the key value pair, which is the table API. It gives us both manual scaling and elastic scaling, auto scaling. So if you create any database and a container within that database, you can configure for both the database level and the container level the request units, request units per second are used per second, which is the currency of the Cosmos DB consumption. You can configure that, and it allows you to independently and elastically scale storage and throughput. So your throughput can be scaled using request units per second, both manually and automatically, and the storage can be increased automatically. It will increase automatically. You don't have to do anything. Choice of consistency. So as we have already talked about this thing, that most of the not only structured NoSQL, NoSQL databases that are there in the industry, they basically support only two of the consistency models, namely your strong consistency model and the eventual consistency model, whereas the Azure Cosmos DB gonna give you five well-defined consistency levels: strong consistency level, bounded staleness, session, consistent prefix, and eventual. It has guaranteed single-digit latency. So guaranteed single-digit latency necessarily means that it gives us 10 to 15 millisecond read and write request latency across the globe at 99th percentile of our queries. So what it means is that 99% of my queries will finish within 10 to 15 millisecond with a properly engineered Cosmos database. And that too, it is backed by money back guarantee through the SLAs. Enterprise level SLAs are of 5 nines with multi-master replication. So if you create multiple readable and writable copy of your database, you qualify for 5 nines, and if you configure geo redundancy, then also you qualify for 5 nines of high availability. You can save up to 65% with the Azure Cosmos DB reserved capacity pricing. It is 3 times cheaper than the DynamoDB or Google Spanner in light of friendly comparison. Then we come to how to optimize the hybrid data estate, that if you have some requirement for IoT edge or IoT scenario, then what you can do. So before that, we have the Azure Databricks also, which is the fast, easy, and collaborative Apache Spark based analytical platform which is optimized for Azure. So Databricks is a company founded by the original authors of the Apache Spark, namely Matt Zaharia. And the best of Databricks and the best of Microsoft are both clubbed of the Azure platform are clubbed in this product, which is Azure Databricks. It is designed in collaboration with the founders of the Apache Spark. It gives us a single click setup for the Apache Spark clusters and also gives us streamlined workflows. Interactive workspace is provided where the data engineers, data scientists, AI people, ML people can collaborate together by writing notebooks and work, right? So there will be no silos between them. It has native integration with Azure services. We don't need to write any integration code for Power BI, SQL Data Warehouse, Cosmos DB, Data Lake Service, Azure Storage, Data Factory, Azure AD, Event Hub, IoT Hub, you name it, it has native integration with that service. And it gives us enterprise grade Azure security. What it means is that Active Directory integration, compliance, and enterprise grade SLAs are offered. Azure Databricks only supports the Azure Active Directory for authorization and authentication for authorization. There is no other way you could go inside the workspace of the company because the security engineers enable the multi-factor authentications on top of these identities. Azure enables insights at cloud scale. So if you look at the modern requirements of the companies around the big data analytical processing, where they have all sorts of data, business and custom apps, structured data, files, unstructured data, images, videos, unstructured data, logs. Appropriately, we can ingest them in a batch using Azure Data Factory. The Azure Data Factory is Microsoft's data integration service, which allows us to copy the data from one location to another, author advanced pipelines along the data integration flows, create the mapping data flows for code free data transformations, for resolving data cleaning issues, and for data auditing and data quality issues, and also for the disaster recovery setup of the company. So we can bring the data from the Azure Data Factory using the Azure Data Factory from these data sources through a batch process and put them into the centralized lake of the company in the ADLS Generation 2 service, Azure Data Lake Storage Generation 2. So the Azure Data Lake Generation 2 is a big data lake for the on the Azure cloud platform, and it gives us the full hierarchical namespace. It is Hadoop distributed file system. You can think of it like that, that it is a fully compatible, not only compatible, it is not HCFS, Hadoop compatible file system. It is HDFS, it is a Hadoop distributed file system. So we can perform analytics on top of this Azure Data Lake. It gives us the full hierarchical namespace file system, and it gives us true portable operating system compliant access control lists. That is nothing but your read, write, and execute permissions that you give on file and folder level. So most of the companies have the requirement that in the lake we are keeping big data, and we cannot give somebody full read access, full write access, full execute access at the full folder level, which is containing gigabytes of data. So is there a way to give the users of my company granularly the permissions, read, write, and execute the way we give it on Linux and the way we give it on Windows? Yes. So the data lake is totally compliant with the portable operating system ACLs, access control lists. Then you can prepare this data, prepare, enrich, transform, train this data using Azure Databricks, which is highly performant and resilient data crunching tool in memory analytical platform for us. You can serve it through the structured data warehouse and then report it using the Power BI as usual. The Azure Analysis Server can also kick in over here with, bet- between the serve and reporting phases. Between the serve and the reporting phase, you can also have Azure Analysis Server, which will act as a caching layer between the data warehouse and the Power BI so that the Power BI reports are interactive, truly interactive, and very, very rich. Azure enables insights at cloud scale. So here you can see they are writing the same thing that I told you, that Azure Data Factories for Azure Hybrid Data Integration ETL service at a global scale. Using the mapping data flows within the Azure Data Factory, you can have code-free data ingestion from 75%, 75 plus, I'm sorry, data integration connectors. Azure Data Lake is a highly scalable data lake solution for big data analytics. You can execute on top of it unified SQL query, USQL queries with 99.9% high availability SLA. Using the Azure Databricks, which is a Spark based in memory analytical platform, you can execute 10 times faster than the vanilla Spark. Excuse me. So, and then in the serve phases, you can have Azure Synapse Analytics. Azure Synapse Analytics is a SQL based, fully managed petabyte scale cloud data warehouse, which you can use for your OLAP requirements, and it is 1.67 times faster than the Amazon Redshift. Then you also have Power BI for your self service business intelligence BI requirements. If we talk about the data platform advantages about the Microsoft, it is intelligent. It gives you lot of intelligent insights out of the box, which you may be not able to gather without advanced database administration or advanced advanced storage administration. Automatic query tuning along the lines of dropping the indexes, creating the new indexes, and statistics updates, and all of these things are automatically taken care by the Azure platform. It is trusted, as we have already talked about. The Azure threat protection is there, and Azure IP advantage, which is the private link support that Microsoft gives us, where we can deploy our PaaS service within a separate virtual network, and it will be only accessible from that virtual network, which means it will start acting as a IaaS resource, infrastructure as a service resource, with its own private IP, highest security requirement, that is. Then you have hybrid also. So already always on with secondary replicas in the cloud can be done using the premium and the business critical features. Transactional replications can be set up using the distribution and the replication. And the data sync between the on premise and the cloud can also be configured using the Azure Data Sync. It is productive. We don't have to take care of a lot of administrative tasks that we have to perform. It will be auto performed by the platform for us. By default, 4 nines of high availability are offered, which is very high as compared to what we see typically on prem. Built in high availability is there on all the services with always on availability groups, distributed always on availability groups in terms of active reserved application and the auto failover groups. And the shorter failover duration is guaranteed because of the accelerated database recovery process, where the transaction log checkpointing is done for us, where it only looks at the previous checkpoint rather than reading the full transaction log for database recovery. So the database recovery will be performed in constant time for us, and that would be very, very amazing feature on the Microsoft data platform. Talking about the Azure Data Factory integration, the Azure Data Factory is a data integration service which is truly serverless, scalable, and a hybrid data integration service. Here we can author hybrid pipelines which seamlessly span on prem, Azure, other clouds, and SaaS. We can run them on demand, which means we can trigger them manually, we can create a schedule for them, data availability or on event, that is in a tumbling window. Our data is loaded and we also run a pipeline in tumbling windows, or we can also do on event, right? We can also do on event. Data movement at scale, you have 75 plus connectors provided up to 1 GB per second of integration unit bandwidth. You can also execute your pre-authored SSIS packages on the Azure Data Factory using the SSIS integration runtime. You can author and monitor using the multi-language SDK support for Data Factory and also the Visual Studio tools. Then we also have the Azure SQL Data Warehouse that you must understand. And this Azure SQL Data Warehouse is now referred to as the Azure Synapse Analytics. As we already know, Azure Synapse Analytics SQL pools. It gives us the industry leading query performance on the TPC benchmark. It is number one for 30 terabyte query processing, concurrent query processing. Highest concurrency for cloud data warehouses is only available on the Azure SQL Data Warehouse. Elastic compute scaling and ability to pause and resume is available. That is nothing but your query engine pause support is there. So you can stop the query processing engine whenever you do not have any ETL workload or ad hoc queries or reporting queries. You can stop it. Globally available in most regions. So it is available currently in 33 regions, and now it is in general availability across all the regions. And it has native integration with the data ecosystem like ADF, Power BI, QClick, Informatica, Talent, MicroStrategy, all of these things. So best in class tools for developers, built in advanced security features on the best end to end platform for analytics. Last but not the least, we also have to bring in the discussion along the lines of the IoT systems. So if you have microcontroller units that you are using for your IoT edge scenarios, then if you want to have a data store for storing the data that you are gathering through your IoT systems, then Microsoft provides the intelligent cloud as well as the intelligent edge, Azure IoT Edge, which gives us a comprehensive offering along our data strategy. So if you want to store the data in the s- databases hosted in the edge, that is also possible. So if you look at intelligent edge with Azure SQL Database Edge, we can have edge microcontroller units, interactive devices which are streaming the real time data, edge gateways. When we have data center and cloud, we can have SQL Server and Azure SQL Database. They are the number one data engine with full AI ML capability for enterprise class mission critical workloads. On the other hand, for our edge scenarios, we have Azure SQL Database Edge, which is an offering for storing the data of our IoT systems. It is hosted in the edge. It is a resource light turnkey ML capable data engine running connected or offline for edge. It is consistent data analytics engine running natively across edge, data center, and Azure. So you can see that the Azure SQL runs across the entire spectrum of the deployments, as a result of which it gives you the capability to deploy it wherever you want and use it for your requirements, right? So we have looked towards all the four aspects of how to optimize your hybrid data estate: data modernization on premises, data modernization to Azure, thinking about globally distributed data using Azure Cosmos DB, and cloud scale analytics using the Azure Synapse Analytics. Azure Data Factory will play a very important and critical role in the data integration tasks. And also for IoT, we have the Azure SQL Edge, which will allow us to deploy our SQL database in the edge and put our data of the IoT systems over there. Now we will take the questions. So let us go to the questions and let us see whether we have questions. So now we're going to be opening the webinar for Q&A. So people can now pose their questions and we will be taking the questions.